Ciao a tutti. This is Prof Jo at Prof Jo Explains. And tonight, Prof Jo is explaining nothing because Prof Jo has a real expert on forensic genealogy and the operation of DNA. And I thought you all would be really interested. I know we all hear in these criminal cases that they're using DNA. They can give you those huge numbers about how sure they are that somebody is a match to the DNA they found. But I thought you might like to hear somebody really explain it who knows it extremely well and is just, foremost expert, doesn't describe it. She has 2 books in the area. She's worked on several hundreds of major cases. And we're going to talk about some of what she's done. So I'm not going to give you her whole profile now, except to say she has an absolutely amazing background. And it's Colleen Fitzpatrick. So we're going to welcome her on right now. Hi. Good seeing you.
Everybody. Yep.
Yeah.
Thanks for the invite.
Yeah. Before we go into what you have done, and it's an amazing, amazing resume. I mean, I was trying to count how many careers. From a PhD in nuclear physics, moving into this area. And I'm going to go through it a little, but why don't you give us a little of your background? You were born in New Orleans.
That's right. I am the oldest of 4 children. And I live in California. They all live in New Orleans still. I went to Catholic school, all that stuff. And then I have a Bachelor's of Arts degree in physics from Rice. And then I have a PhD in nuclear physics from Duke. And I taught for a couple of years at Sam Houston State and then went into industry. So I didn't really stay in nuclear physics. I kind of transitioned into lasers pretty quickly. And I got interested in holography while I was at Sam Houston. And that pretty much represented the next 16 to 20 years of my career. So I eventually got out of academia, went to Rockwell working on Star Wars and laser measurements. And at the same time, I had a hobby, loved holography, making holograms. So when I moved to California, I set up an optics lab in my garage. And so by day, I was an aerospace engineer. And at night, I was in heaven with my own lab to do anything I wanted. So I, taught myself hologram. I did a lot of artwork and stuff with friends. And then I got a job actually working with a company called Spectron with all of the, experts in laser measurement techniques. So I did that. And then eventually when I got laid off because Star Wars was going away and the company had been sold, there was a lot of things going on. And I went off on my own in the late 80s. But I had my optics lab and my laser lab in my garage, and that's how I started my company. And that lasted for another 16 years to about 2005. And during that time, I contracted with NASA, the Department of Defense, Army, Navy, Air Force, DARPA, all those people. And then finally, in the early 2000s, when President Bush took over, he was more of a big company guy with Iraq and in aerospace, and we really couldn't, compete. A lot of the smaller companies got chewed up. So we eventually closed the company. I had a partner at the time. And about that time, my first book called Forensic Genealogy was done because that was my therapy while all this was going on. Well, the walls were burning down around me. And it was about done the day we were selling furniture for the company, So I had a contract with a publisher. And after working on the book for 3 years, he told me he didn't want it anymore, that forensics was passé and to forget about it. So I was sitting there with a book already done, except for maybe final editing and a cover and stuff. And my partner, who had worked for the United Nations for 30 years, said, why don't we publish it ourselves? And I said, we can't do that. And he says, yes, I can. Yes, we can. I worked in a book bindery in Nigeria, and it's not that hard. And I went, they have books in Nigeria? I mean, think about it. And so that Kodak moment stopped me, from doing something like jumping out of a window or something. So we did. We didn't upload anything. This was 2005. We actually opened a publishing company to do our own stuff. And so we published a book, and it was a smash. And so, rocket science, laser stuff went away in place of forensics. And I had already been kind of doing my own genetic genealogy, Fitzpatrick studies. So, it was naturally that, that was part of the book. It was how to identify old photographs, how to use data, and also DNA, the 3 parts of the book. Well, it was a smash. And based on that, I started getting gigs with the Armed Forces DNA identification, because I have a scientific background, so I could talk turkey with these people. So that got me into the Hand in the Snow, identifying the frozen hand in the glacier in Alaska from 1948. And then that led to the Titanic baby, which led to the Amelia Earhart project, which led to Abraham Lincoln stuff, which led to military identifications, which led to a whole bunch of Holocaust research. I reunite Holocaust survivors with their families. One case has been made into a documentary recently called Toy Soldier.
You've broken up.
And then that led to 2011 was asleep. Okay. So that led to about 2011 when I was falling asleep, and I said, you know what? The people in genetic genealogy use some of the same markers that the law enforcement use on their cold cases. I wonder if I could apply, they could give me the Y profile on a case, a certain piece of DNA, and I could match it to genetic genealogy databases. I bet you I could get the last name for their killer, because that's the male line. So I made an appointment with the Seattle Police Department, and I said, hey, you can use genealogy for cold case work. Well, I almost got laughed out the room, so I figured, well, I lost the battle, but I'm not going to lose the war. And that led to where we are today, where that whole thing exploded, has developed. That was a Sarah Yarborough case, and that became the first case attempted with genealogy. 2015 was the first case solved using genealogy. That was the Phoenix Canal murders. That led to Joseph Newton Chandler and Buckskin Girl. That was using, technology had advanced. So that was using like the big genealogy we use now. Let me call it that. And then that led to DNA Doe Project. It led to all kinds of John Doe cases and violent offender cases that I've been involved in. And of course, now it's spreading internationally, and there's been thousands of cases solved by many people in many organizations.
I said several different careers in one person. It's, I do believe that some people manage to have, I don't know how they do it. I don't think Einstein ever described it, but you get more than 24 hours in a day than the rest of us. And you clearly are among the people I would designate as being able to do that. So is there something that you've done that you find particularly gratifying, or was every transition, every place that you were in any given time really gratifying, and then you just moved on to something else?
Well, I want to say what I'm happy about is it worked. I'm a nerd, I'm not out there, oh my God, my idea is going to make me $1 million. No. I'm like, hey, I wonder if this works. Let me wind it up. Oh my God, it works. I'm so happy. Let me go tell my friends. And I'm not thinking I just invented the next mousetrap. I'm sort of like that. So in general, I'd say I'm just happy it worked, that actually I had breakthroughs, that I did a whole bunch of firsts, and that and then I think, hey, that really brought some real nice peace to people who had been wondering. It brings them a release from their terrible tragedy of losing their family member. They can take a breath, and they don't have to worry that the guy's coming back for them. He's just a creep, and he's going to be in prison the rest of his life. Take a breath. Your loved one, your daughter, your son, your mother. You know what happened. It's all over. You know where they are. They're okay, wherever they are. And now you can let that go and come to terms with the past so you can go to the future.
Yeah, it's a wonderful gift you give them. I know there are going to be people with all kinds of questions, and I hardly know where to start, but I guess one that would interest me is the work on Abraham Lincoln. What was it that you did with regard to Abraham? Didn't we know who he was?
Well, yeah, well, it was with a professor who I believe is at Tufts now, and he was interested to see if Abraham Lincoln had genetic disorders, and they're called orphan diseases because they don't have, a lot of people don't have them, so there's not a lot of money put into medications, or treatments. So there were several, and he what he wanted to do was let's see, he wanted to get a sample of Lincoln's hair and do the whatever processing and find these markers for these diseases. And there was so what happened, he had three, I think 2 or 3 relics from Lincoln. I mean, he had a lock of hair somebody gave him. We don't know if it was Providence or not. He had, let's see, a cloth that was supposedly from Lincoln's death sheet called the Tuckerman sheet. And I think he had one more item. Oh, yeah, a strip of the pillowcase from the GAR Museum. And he had swabbed those, whatever. And then we had to trace his family to get a family reference to compare it against, right? You get that. You need to compare it against a living relative. So what happened was that the problem with that is that nobody really knows where his mother came from. They know who she was when she got married, and she died when he was 9 years old. And that was like in 1818. And so there's very few records of who she was, where she came from, who her parents were. So what we did, we rounded up 2 candidates. Like if you look through history and you do that, her name was Nancy Hanks. If you look through all of the records, there were 2 candidates that kind of stand out from the others. And we'll call them Nancy number 1 and Nancy number 2. So Nancy number 1, let me say this. Lincoln had a sister and a brother. The brother died when he was 3 days old. The sister died in childbirth, and her baby died. So Lincoln was essentially the only one who had any children. His line has died out in the 80s. His last living descendant was gone without any more descendants. So when you look at that, in order to get a family member, you have to go back really to his mother, because you have to do the maternal DNA for many reasons. It's easier to work with. So when we did that, nobody knows who is, his mother's history and who were her brothers and sisters. And so we had 2 Nancy Hanks as candidates. And Nancy Hanks, number 1, did have sisters and brothers, and we got a descendant from that Nancy. And the other one didn't, she only had Lincoln, and there was sort of some speculation. Her mother was another family, she belonged, and we got a link to that one. We thought her supposed mother had been married again with children. So we got some of those lined up. So we had 3 relics, let's say 2 relics, I'm sure of. Now let's say 3 relics, and we had 3 Nancy Hanks candidate descendants, 1 and 2. So we tested everything, and we were hoping they would all match and we could be happily ever after, right? Well, the relics, none of the relics matched each other. They were probably contaminated by people, And then the worst part was, none of them matched the Nancy Hanks descendants. So our experiment failed. But it was even worse than that, because all of the Nancy descendants match each other. So the 2 Nancys we can't distinguish, right? We think they may have been the same person because the records are so scarce. So none of the relics were worth anything. All the Nancy Hanks's descendants, and then the worst part of all. So we can't go anywhere with that. But when you look at the maternal DNA, mitochondrial we were using, it goes back to a very rare population group. And the name of the group is X1C. Just keep that in mind. You don't have to understand why it's called that, but it's called X1C. And there were only 2 samples of this kind of DNA found in the world up to that point. One of them was in Tunisia, and the other one was in Italy. This DNA, so it turns out Barack Obama may not be the first African American Islamic president. You get that?
Huh.
It might have been Lincoln. Got that? So my desire, it's very hard, if not impossible, to get any Lincoln relics. I have been through the community and I'm still talking to a few people. If anybody out there has a bona fide Lincoln relic, contact me immediately, because I know how to do it now. We have I can prove it's Lincoln's relic because of, the genealogy we do. I wouldn't have any problem. It's just, and, I actually can get funding to do some of that. Believe me, it would be world news if he turned out to have his mother was part of African American. So, North African. There's a lot of discussion. There's a lot of reasons why that might be right, because Queen Elizabeth and, the whole geopolitical, there's reasons why people from that area would have been in the UK and they would have come to America to settle in Virginia. There's all kind of reasons. So that has to stop there, because we think he was African through records that aren't complete, let's say. Okay. But
if I heard you correctly, if I was following you correctly, he also might have been the first Italian president. Is that right?
There you go, Dr. Patuto. Yeah, oh yeah, okay, I get it. Yeah,
this is the daughter. Oh. I noticed you were the daughter of Irish immigrants. I'm the daughter of Italian immigrants. So
there you go. Well, maybe we should start talking about that. Maybe that supersedes. Trying to think. I'm not sure we've had another one of those. He'd be the first, wouldn't he?
And so Amelia Earhart, was that attempting to identify whether remains or that they had come across over the years might have been she?
Yeah, and I just started tracing her genealogy. I had been talking to Tiger, it's the well-known Amelia Earhart project, to find her. And I kind of went independent. And I don't have time for the blogs and the chat. I just went, and the Amelia Earhart's well-known and her family is well-known. DNA is available. You ask them, you can find that. But her navigator, Fred Noonan, was not very well known. He was separated. He didn't have any children. His mother died when he was 4 in 1896, something like that. So when you start tracing Noonan, her name was Green. When you start tracing, it's hard because there's lots of Greens in the world. So I spent a year and I finally got the right relative to give the DNA. May I be excused a moment?
Sure.
Hold on.
It's amazing, isn't it? She not only knows the science, she has to know the history.
I have the DNA sample of that family reference for Fred Noonan in this very envelope. So if they find the crash sites and there's DNA,
you're ready.
I'm up to the highest bidder. Here it is. What bidding starts at 1 million. This will prove whether that's Fred Noonan or not. I got to put it back in the refrigerator. Sorry for the interruption, but I thought the audience would like to see that.
So do you spend most of your time now doing identification for law enforcement in the criminal area, or are you doing other things besides that?
Yes, I do. I'd say most of my time. I would like to say I do a tremendous amount of Holocaust research as well. I have my cases, Holocaust cases, there's one left and it's 13 years old. I've been working on it for 13 years and we think we just may have found her. I think we found her dad. I think we just found her mom, maybe, but we have a candidate for mom. Took 13 years. Because she was smuggled from the Warsaw Ghetto in 1942 as a tiny baby. Nobody knows.
And they lost track of her. Yeah. Did she do you think she survived the Holocaust?
She did. She lives in Israel. She's a great grandmother.
So I suppose where we need to start is for you to explain to the non-scientists among us what DNA is, how it operates, and how you're able to use it to identify people.
Yeah, well, guys, I'm sure people know DNA is basically all of the chemicals or the whatever's in your body that makes you who you are. Your blonde hair, your skin color, your ability to taste things, your genetic makeup. Everybody has 23 pairs of chromosomes. They are match sets. You get one from your mom and you get one from your dad. So you have 2 chromosomes in each pair with 23 pairs. They are match sets except for the last pair. The last pair, the 23rd pair, tells you the gender. Because a woman has a match set, they have an X from their mom and an X from their dad. I have a match set. However, men don't. They get an X from their mom, like I did, but they get a Y from their dad. So if you have a Y, you're a male. And if you're a male, you have a Y, and you inherit that directly from your dad because he got it from his dad, So the Y is like a tag for a male. And genealogists use that to try and to use the Y to try and research their family names because that's where the name comes down the line through the male line. So in about 2000, I had my brother tested to see Fitzpatrick's because if I could find a Fitzpatrick that matched him, that would be a relative of mine. And I could sit down and talk to them and say, how come you're from New York? Wait a minute. How did you get there? You're part. And then we could put our heads together and try and figure out how that happened. And then that would help my genealogy. So that's kind of, that is, how it all started and why the Y DNA was so valuable. And in the early days of using this for crime, I realized that, the genealogists are cranking out their Y DNA and trying to find relatives. Woo! Well, on the other side of the fence, that was the same markers that the law enforcement was using for their cold cases. They were using it in a different way, but it was the same markers. So one night in 2011, as I was falling asleep, I said, isn't that interesting? And then I made the appointment, as I said, with the Seattle police, presenting my idea that if you gave me the Y profile from your cold case, I may walk over the other side, jump the fence, and look in the genealogy database to see if I found a match. It's the same thing as an adoptee would do. If a man doesn't know who his parents are, take a Y test, throw it into the big database. If they come up with the name Fitzpatrick, that's probably their father's biological father's name. So it doesn't matter if you're an adoptee or a violent offender or a John Doe. The DNA is the same. You don't know who it is, use the same data. Try and find out what the name is. So that's kind of how DNA works. And that's how the use in crime and unidentified remains cases started.
Okay. Now that's if I'm following this, that's different from if I'm the investigator and I pick up blood at a scene, being able to, through the DNA, identify I learned numbers the other day that were larger than any I'd ever heard in my life, that the particular suspect looks like he is the one who committed the crime. Is that right? I mean, that's a different version of this.
Completely different. And that's a good point because as I said, the law enforcement uses a completely different system, except for that one small bridge with the Y. Otherwise, what they do is the kind of marker they use is called an STR, and the S stands for short. So you have markers that are this long, this long, this long, this long. They're pieces of real estate and there's 20 pieces. So if you find DNA at a crime scene, you go collect it, you give it to the lab, they do something, they crank the ice cream machine, whatever, and then out comes these markers, the values or whatever they're looking for. And they have 20. So you have a suspect, you get him tested on the same 20, and you see if they match. And when they match, each marker has their own population statistics. 1 in 100 people might have this kind of marker. Another one might have 1 in 1,000. This other marker might be very rare. And then they do the statistics and they come up in 1 in 10 trillion person would have to have that combination than anyone else.
Right.
So they
But that's not what we're using you for, because that sounds pretty elemental at this point. You've got the information. Sounds as though I could do it if I knew how to use the machine. You don't have to understand.
Well, that's all boxed up in the crime lab. You couldn't
Right.
use it. I couldn't use it. And it is developed over 30 years, and it was the best technology for a long time.
Right.
But now we use a different kind of marker, and it's called a SNP. And it's a point. The S stands for single. So it's a point. And we don't use 20. We use 1.2 million of these points. And now we can say, I could say to you, if we took the DNA test, both of us, and I'm an adoptee, and you came up on my list, that, I get my DNA tested by ancestry, 600,000 points. I throw it in there. They put it in a big soup, and they list people that share their DNA with me in certain amounts. Now we can talk about, you can share 10%, you can share 5%, you can share half of my DNA. And they tell you all these people. So if we share half and half, you have to be my parent or my child.
So those,
and then I get a list of all these cousins.
Those 1,000 SNPs is what you call. Would you find them in one drop of blood?
Well, you'd find your DNA in the drop of blood.
Yeah.
And the SNPs, they're all over the place. They're not just on the Y. So women can do it too. Now they're all over. And now we're not 20, we're 1.2 million. So it's almost like marbles in a jar. How many of your marbles match mine? Right? And then we start talking about the more DNA you share, the closer you're related to me. And the less DNA share, the more distant you're related to me. So we're talking about relationships of all these people. And that's where genealogy comes in. Because it's a big Sudoku puzzle. You try and put the tree together, and then one tile is missing. Everything has to be consistent, right? Diagonal, horizontal. And then when you're done, there's one tile that's missing, and that has to be you or your brothers and sisters. And you got to match everybody in the tree just right. And that's
There's a question here, how DNA was used in the Somerton Man case, and you worked on that case. You solved that case, is that right?
Yeah, I solved it with a professor down in Australia called Derek Abbott. Yep, there he is. There's old Carl.
So why don't you tell, this is one of your triumphs. You've had many, many, many triumphs, but why don't you describe this one for us?
Well, yeah, guys, let me say first how the DNA was used. This is a weird case of a guy found dead on a beach in Australia in 1948, and he has been a mystery forever, 70 years. And as I said, what we did was, now this is interesting because when he died and they just couldn't figure out anything about him. Please read about this. It's such a weird story. But let me cut to the chase and say they couldn't figure it out. So they made a plaster cast of his body before they buried him. And it wasn't really realized, but they caught hair in the plaster cast. So Derek Abbott, 15 years ago, sort of took up the case, and he said, well, maybe modern forensics can solve it. And they allowed him access to that plaster cast, which is in the South Australia Police Museum. And he got a forensic anthropologist to come in with a pair of tweezers and magnifying glass and pull hair from the center of the bundles, so they hadn't been exposed to the plaster. And so fast forward a couple of years ago, he sent that hair to the lab, and they got DNA out of the hair. Hair couldn't produce the big pieces they could do for law enforcement, but they could produce the SNPs. That's a breakthrough for us. So we used the SNPs, we used the Sudoku puzzle I explained, and we put it together, and we identified him as Carl Webb. We did not use Ancestry. I want to make that clear. We don't use Ancestry. We have other databases we use. We don't use Ancestry. We don't use 23andMe. We don't use MyHeritage. So I know that adoptees use that, but law enforcement has to do something different, but it's the same process.
And this is the type system that would be used for John Benet Ramsey, for example?
Yes, it could be. Now, I assume they already did the law enforcement stuff. They're looking for suspects. Remember the guy from Thailand that said he did it and he came? Well, all they had to do was take his DNA and compare it to whatever they had. I don't know anything about that. I'm assuming they did all of that and they found out that's not him. So now you have to have a suspect when you do the old way. That's the problem. So with the new way, you don't need a suspect because you have all the DNA cousins that are going to lead you to the answer. And that's what I think he'd like to do.
Mm-hmm. It's amazing, just amazing. So are there any I don't want to, there's a question in the chat. I would do it now. Otherwise I've got, lots and lots of other questions that I can do. So anybody want? I don't see. Okay. So we've got someone who wants to know how the boy in the box case was solved.
That's Amber again. Oh, she's got so many questions. He asked about the Somerton Man. See, I'm paying attention. The boy in the box was probably the toughest case I've done in my whole life. This was a boy found in the Fox Chase area of Philadelphia in 1957. Now, this was, think about you're in your suburban neighborhood walking down the street, or maybe there's a place where there's a bunch of trees and you find a dead young boy. And so this was very, very upsetting. This is out of the ordinary. And there were flyers put in the electric bills. There was 100,000 flyers put in electric bills to see if anybody could know who he was. There was flyers put in grocery stores back in the 50s. That's all you could do. So he was buried, and he was buried in a potter's grave. And in 1999, they exhumed him and they moved him to, and you're going to ask me the name of the cemetery, but they moved him to a much better, somebody donated the plot, and he's right in the front of the cemetery, beautiful place where he was buried. So in 1999, I think that happened, maybe it was a little sooner, because in 99 they had an exhumation. Yeah, that's probably when they grabbed, and they kept a few teeth, they kept a few other bones above the ground. And of course they were hoping to do DNA on it, but in 1999, all you had was the police stuff, and it wouldn't really work with degraded DNA. You can't get big pieces of DNA from degraded DNA, so it wouldn't work. So then there was another exhumation in 2020, which I was present. And we got a few more bones. It was, you open the coffin, it's just a bunch of bones. It's nothing really awful to look at. It's just a bunch of bones. They had in 99, they had put him in a little jumper, so it was bones in a jumper. And the skull was on a nice silk pillow. It was not gross, believe me. So we took a couple of other bones. I have pictures of all of that. And then, there was a group that had already tried the DNA and hadn't made any progress. They just couldn't get enough of good quality DNA. So then after that, seeing as, I inherited the case, I knew we needed better extraction. We need better DNA. And we had really, these bones had been underground for like 50 years, 50, 60 years. The DNA was the worst in the world. So I went to the International Commission on Missing Persons in The Hague. I made contacts with them, and I talked to the director, Tom Parsons, and he agreed to try and get some more DNA from the bones, because, they deal with all kinds of remains from all over the world. It's a really good lab that works with that kind of bad DNA. And they've had amazing success, very good organization. So he did some extractions, and he didn't get anything better. So I said to him, is there anywhere in the world that might be able to help? And he said, yes, that there was a lab in Germany that would help. And I sent it out to the Max Planck Institute in Germany. And it took some discussion because what they do with all the ancient DNA and the mummies, the DNA on mummies is different from what we want, but there's a lot of similarities. It's only what kind of data you have to deal with. It's different kind of reason for doing it. So we had to have some discussion, but eventually they produced data that we could use for genealogy. And from then on, it took a few more months, and we had him. We identified him with the Sudoku puzzle, as I described. We put it all together, and there he was.
Mm-hmm. Very, very interesting. So, okay, Stuart Staubhill is saying that the first UK murderer caught via DNA was Colin Pitchfork.
That's right.
Do you know? He was wondering if you know about the case. He'd like you to talk about it. If you know about it.
Do. Of course I do. And it was really the first case that was used, criminal case was used in 1982. Sir Alec Jeffreys suddenly realized you could do DNA, identify people using DNA. He was looking for certain markers, and he had made, those in old movies, you see the X-ray films with the lines on them, and a scientist is holding up and looking at them. Well, he was doing that, trying to find what markers to use. And he happened to use a mother, a father, and a child as his little experiment. And he held them up, and he realized the child had a combination of the markers from the parents. And he realized, wait a minute, this can be used. It's unique. This can be used to identify people. So a couple of years later, they had two murders out in England of Dawn Ashworth and I forget the other girl's name, separate incidents. They were on the way home, and they got raped and murdered, separate in a small town in Leicestershire. And I'd look up the other name. And people were scared to death. They had a serial killer on their hands. And there was a janitor at the local mental institution who they arrested because they thought he knew too much about the first murder. He didn't know a lot about the second one, but he knew too much. So they arrested him. And in the meantime, they had to prove it. So they said, wait a minute, this guy has DNA. We don't know. Okay, maybe we can use that to solve the case. So at that time, of course, they had the crime scene, but they didn't have anybody to compare it to. So they did a DNA dragnet, and they collected 6,000 people came in to give their DNA samples. And he wasn't in there. This took months and months and months because you were doing it by hand with the X-ray, films. And so finally people were saying, this DNA stuff, we have doubts about it. And, while they were wrapping up and discussing this, a lady went to a happy hour one night, and she was sitting there, and another guy at the happy hour was laughing or he was explaining that he had been hired to give his DNA sample to the dragnet by somebody else. His friend said, give your DNA because I've been in trouble with the police and I just don't know the DNA. I don't want to get tangled with all this. So the friend was talking in happy hour. I gave my DNA for a man whose name happened to be Colin Pitchfork. So of course she goes to the police and she says, guess what? Let me tell you what happened. And they go get Colin Pitchfork, and he's a match. And so he became the first man convicted using DNA. And also that custodian at the mental hospital became the first man exonerated using DNA all at one time. And DNA was like thumbs up. You see, I told you it would work. That's, And look where we are, so many years later.
So what does it mean to have degraded DNA?
It's when the DNA just falls apart over time. DNA is a huge molecule. All those chromosomes are big. I mean, not big as we are, a little teeny thing, and so they're very complex chemicals. And when you have water, humidity, temperature, they tend to fall apart. So if, Boy in the Box was buried for 50 years, 50, 60 years, that's going to really, your DNA comes out like confetti, right? It just it's all chewed up. And the thing about the Somerton Man that saved that was the DNA was inside the hair, right? So it was, in a way, insulated from all of that stuff that would have destroyed it.
But you've been able to work with degraded DNA, haven't you?
Yeah, because we use markers that are SNPs. They're single point, they're little teeny guys. There. So you have, you don't have big pieces, but you have little.
Is it still as, I mean, I'm thinking my analogy would be to fingerprints where you only get a partial print. You don't have the full print. Is it still, is your identification as reliable when you've got degraded DNA as compared to DNA that isn't degraded at all?
Yeah, I mean, let's say this, there's a point of no return. If your DNA just completely or you have not met much DNA, there is a point of no return, but we're pushing that limit more and more, less and less. So you can have basically DNA that's confetti, and the crime labs go, look, we can't deal with this. It's so broken up and we can't. And they send it to us and we do the Sudoku puzzle and we get it. And at that point, I want to say that is until now really considered an investigative lead. You don't say, hey, they pointed in genealogy, we know who it is. You have to still go back to the crime lab and the STRs and the police and get some kind of proof that can be presented in court.
Well, you must get a lot of requests. How do you decide which cases you're going to actually work on? I'm guessing you can't do them all.
Well, we have the capacity. We don't turn a case down unless it's really, no, we don't really turn a case down. That's not to say all of them get solved. That isn't to say all of them, the DNA just is great and we can work with it. But, any case that comes in, we'll at least listen to the law enforcement officer. The only exception where you really can't do real well is when you have a mixture. If you have a sexual assault, you will have a mixture of female and male. And what we do is very limited on the mixture end, so if you have, there's, exceptions here and there, but really that's the only case we would say, look, we really can't help you on that because technically we can't, the technology doesn't work, but they're working on to get it better.
Well, what's your turnaround then? If I were a detective and came to you and said, I need help with this, and you're going to take a look at it and see what you can do.
Yeah.
What is my wait time likely to be?
Well, you see, first of all, it depends on the lab. We don't get the DNA here. We are general contractors, and we say, okay, let me talk to you about your DNA. What do you have? Okay, and then we pick the lab that might be the best, because different labs have different personalities. They're all great. A lab might be down because they're adjusting their software, or they may be installing new equipment, or somebody new, they're training somebody new. So we know all of that, and we direct the DNA to a certain place. Now that will take anywhere from, you might hit the boat right as it's leaving, right? Might take a few weeks to a few months. And then we have to do genealogy.
So what's the value added? Why couldn't law enforcement go direct to a lab and ask that? What are you doing as the intermediary to facilitate that process?
Well, okay, there's a couple of things. They could do that, and many agencies are doing that now. But you understand, after 30 years, there's a learning curve. And these law enforcement officers have been using the STRs and CODIS for 30 years. They can't do that anymore. This is complete, even though generically it's the same, where you get the DNA, you look at the evidence, you send it to the lab, you put in the data, you look, but it's a different lab, a different profile, a different hit. It's different. So there's a learning curve, and there are a lot of agencies that are actually doing it in-house now. New York's Police Department, NYPD, has a whole genealogy unit now. Orange County, I worked with Orange County here in California, but a lot of agencies don't have the capacity. They don't have the staff to do that. They don't have the funds to hire somebody to develop that. So they will go and they'll ask somebody like me, listen, we have a case. What do we do? I say, okay, tell me about the DNA. We'll pick a lab for you. We'll from front to back, we'll stand with you and we'll get you forward on that. So a lot of people, it's like I did my own plumbing for a long time. I did my own car stuff. I don't want to do it anymore. I don't have anything to prove. I just hire the plumber and the car mechanic, and I'm happy.
Mm-hmm. And that's then the same thing you would do if I'm a family member and I'm looking for a Holocaust survivor. You would find.
Well, yeah. I know the Holocaust survivor I can do on my own because that's just like genealogy.
Okay.
It's not law enforcement anymore. But it would be similar. They could take an ancestry test. That would be. I wouldn't have to pick a lab. I wouldn't have to. I could just say take an ancestry test. We'll do your genealogy. It's more than that, of course, because you've got to get the records and build a It's not easy, but it's easier because it's like an adoptee case. Somebody doesn't know their parents.
Well, Twist has had a question up here for a while, asking if there's a case out there you'd like to be involved in helping to solve, or one that got away from you. I assume he means somebody else got to do it.
Well, our community, let's say the word is dynamic. So people do steal things here and there and everywhere, and not steal. I hate the word steal, but let's say get in line in front of you without you knowing it. Let's do that way. I actually, and there are a few, but you go on, I don't steal cases from other people. I let the agencies come to me and say, if they want to, they say, listen, XYZ isn't working out. Would you like to have another look at it? And I'll say, well, sure. If you want that, it's up to you. We don't like to step on anybody's toes, but we're absolutely, glad to help you with that. We don't go out and there are people that do that. We don't do that. We have enough work. And then they asked, in the one case that actually I am involved in is the Lindbergh baby case. And that is, there's a whole bunch of ransom notes that are, and there's DNA under the flaps and envelopes, and stamps. And I'm very interested. I'm already involved in that. It's a very long legal process we're involved in right now to get access to those. And if we can get DNA from there, who knows whose DNA? I want to know. A lot of people want to know who wrote those land.
Well, that's a New Jersey case. Could you get DNA from the latter, skin, and work from that?
No, not the letter, not the envelope body, because they're all contaminated after almost 100 years. You have to get it from underneath the flap of the envelope where somebody licked it shut, or from under the stamp where somebody licked the stamp. And they have been able, there's a big study on stamps and envelopes, and they've been able to get DNA back to 1865.
Well, I would venture to say, as famous as you are now, if you solved the Lindbergh case or confirmed that Hatman was the kidnapper killer, your name would explode beyond where it is right now.
Well, yeah, I'm just, like I say, I just want to see if it works. I just want to see who it was. I'm not, I guess, I'm not really, I don't know what fame is. I guess I enjoy being recognized for what I do, but fame maybe means even more than that. I mean, what is that? What is fame? And I'm glad people, really appreciate what I'm doing. And, they recognize me. I enjoy that. And when I submit it, and I want to give a talk somewhere, somebody's going to know who I am and wants me to speak. And I enjoy getting up and speaking about stuff I've done.
Yeah.
And I guess there is ego in that, but it's not like I want to be in TV 24 hours a day and have my own jet and be a, rock star that has billions of dollars and stands on stage. No.
Yeah, but it's got to be nice to be recognized for the great work you've done and the accomplishments you've had. I mean, I would say if I were doing something that was really significant, I would want people to know about it. Maybe it's just
Yeah.
that I'm not sufficiently developed in terms of, but I would want people to know, look, this is my
No.
work. That's a
Yeah.
great thing.
Yeah. No, I agree. I don't want I want to be recognized for what I've done, not for any more or any less. Exactly
Right.
what I've done. I want people to appreciate it. And what I really like, I think, is that, let's say this, I'm talking for an hour or so here, and you hear all of the stories, all the success, people want to know about this and that. But, it has not been easy. There have been, some real disasters. There have been some real hurtful times. There's been some up really highs and really lows. And enduring all that, that's who I am today. And I can see other people in life and share my experiences with them. And I know a very good friend of mine recently said, "Do you remember you gave me advice one day?" And she said, "I almost made a real terrible decision, and your advice changed all that, and it really saved my life." And that is one of the most meaningful things I have done.
Mm-hmm.
All of the violent offenders aside, and that having that connection with somebody who understands that I understand what they were going through is more than probably a lot of other things.
Yeah. So you had involvement in one of the victims of the Titanic, is that right?
Yeah, that was the Titanic baby.
The Titanic baby. Wouldn't water, if I'm following you, I've been learning a lot, so thank you. Wouldn't water degrade the DNA or no?
Listen, yes. Well, the baby was found within a week. So
Oh,
when the Titanic went out there, and there's that Amber woman again. Yeah, they sent a salvage mission out from Halifax, and they collected 300 something bodies, of which probably 100 something were buried at sea because they didn't have enough embalming fluid and coffins and all the stuff. And one of those was a baby. So the baby was brought back, given a beautiful funeral. The crew of the boat that pulled the body out was allowed to adopt the baby and sponsor the funeral. So it was buried in Fairview Lawn Park Cemetery with a lot of the other victims. And in the 90s, there was almost no description as child. It was an index card that said about 2 years old male wearing like a little petticoat with shoes and everything. So in the 90s, there was a Swedish family that thought that was their relative. So they petitioned the Canadian government to exhume the body, and it took a couple of years to get that request filled because it was a National Heritage Site. There was a lot of red tape. And when they finally did, and they opened the grave, they found it wasn't the problem like in the water in the ocean. The problem was that this area has been rained on in Halifax for 90 years. So that's what the problem. It was acid rain and it was damp, and that's bad for DNA. So when they opened the grave, they found a little tiny piece of wrist bone and 3 baby teeth. And they were not, real solid baby. I may have been cracked open, but one of them had soft tissue left. So they used that to get DNA, and that Swedish family was not a match. So they had 5 more children on the manifests that were male, that were 6 months to 2 years old. And they ruled out 3 subsequent. When you do this with mitochondria, you don't do the whole thing, you just do one piece. So that one piece was able to rule out 3 of those 5. You had 2 left. And when they looked at that one piece, the 2 children were identical. So they looked at a second piece, and essentially the children were identical again. So what do? These 2 children, one was a baby from England called Sidney Leslie Goodwin. He was 19 months old. They had another baby who was from Finland, who was 13 months old, named Aino Panula. Now, because the DNA matched, they had a common female ancestor within the last 2,000 or 3,000 years. and the DNA had been handed down, and it was virtually identical.
And they both ended up on the Titanic.
Yeah.
What are the odds of that?
So this was crazy. So they brought in pediatric dentists, forensic odontologists, got all these experts, and they said because of the root formation, your teeth grow from the top down. So no root formation, the surfaces were smooth, so it was a child on soft food, and all. They said it had to be the younger baby, the 13-month-old baby, the Finnish inopanula. Big party, big announcement all over the world. Everybody's cell phones are going off. And then the trouble started because the shoes of that child were in the museum, the Maritime Museum, and they were too big for the 13-month-old. They would have fallen off in the water. So back to everybody said, "Oh, DNA is so stupid." What? It wasn't DNA. So they went back and they did actually SNP testing. They SNP tested, and they were identical again. So then I helped out. What I did, I tried to get the Y DNA and get a male because these were boys, and they didn't have any more Y DNA. It was gone. So then they said, okay, we're going to look in the literature and find more markers, more SNPs that are not in the lab. They're still in research mode. And we're going to find a couple of those that might help break the tie. And that's what they did. And it turned out that the English baby was the baby. The Finnish baby dropped out when they did the extra test. And the baby was a 19-month-old Sidney Leslie Goodwin. And once they used that DNA to make that final test, the DNA was gone. So if it didn't work, we would never have known.
Yeah.
Every time they didn't have that much DNA to start with, they had to keep testing it. The section 1, the section 2, the SNPs, bye. Well, here's me again. I thought your name was Stuart. Right, that the FBI now has a database like coded DNA where investigators do direct from the crime scene. No, what you're thinking about is rapid DNA, and that is my understanding is it's like an instrument, and you can get, instead of sending the DNA to the lab and waiting, you can actually do preliminary results right on the rapid DNA and get the CODIS markers and compare it to the database very quickly. And it's not just the FBI that has it. It's a lot of agencies. New York has it. Phoenix has it. It's getting to be more common, and it's very quick. And you could, that helps because you have somebody that you're going to take to the station in question. You don't have a whole lot of time to hold them, How long was the Phoenix Canal case? It was a few months. They had to give me the Y profile. And once I did the Y profile, it took me a few days. And then I sent it back, and I was just went on my way in life, not even thinking about it. And then I would say, I got an email every now and then from them about this or that genealogy stuff. And then one day, it must have been a couple of months later, it only took a few months, they had to do their investigation. They had to give me the Y, kind of made all that decision process, go up the chain of command. Then they gave me the Y, I did the work, turned it in, and then it was nothing for a long time. And then after a couple of months, I was in a restaurant with a friend of mine, and the phone rang at 8:00 one night, and it was the Phoenix guy, the Phoenix detective, and Troy Hillman. And I said, "Excuse me, I've got to take this. I don't know why he's calling me at 8:00 at night, 9:00 in Phoenix." And he said, "You were right. The name's Miller." And I was like, "Oh my God, they got him." And the whole restaurant was like, "What?" I said, "Wait, wrong number. Sorry. Everybody go back to him. Sorry." And that was, Miller was the right name. When I gave him that name, it took him about 20 minutes to get him as the person of interest. There were 2,000 people in the case files, and that narrowed it down to 5 Millers. And of the 5, there was only one really kind of strange guy that you'd look at first, and that was him.
See. Well, we've been going about an hour, and I don't want to impose on your willingness to
Well,
talk to us. But
no,
I do have a question for you. When I was going through the materials and your biography, I came across something called the Vidocq, Vidocq Society in Philadelphia, and
yeah.
I'm very curious about it. So can you tell us a little?
Yeah, you should read about them. There's a book out about them called The Murder Room. And what it is, it was, oh, this is amazing. It was formed in the late 90s, maybe 98, 99, by three people: Frank Bender, a forensic artist; Richard Walter, a forensic psychologist; and Bill Fleischer, a detective for Philadelphia Police Department. And there are 82 members, and the only way you can become a member is one of them dies. And it's named after Vidocq, who was a French detective around the turn of the 20th century, one of the founders of modern forensics. And the group meets, I can't go because it's in Philadelphia. I go once or twice a year, but group meets once a month at the Union Hall in downtown Philadelphia. They have lunch, and they invite an agency to come and talk about their cold case, and they brainstorm. And in that room, there's detectives, whoever shows up, the forensic, I do DNA. Hello, Karen from UK. And, there's all kind of forensic brainstorming go on. And they give the detectives, some not interesting ways to look at it and think about it. And then the agency's welcome to come back and have an online post-presentation working group, whenever they're ready, just to follow up on some things. And so it's, we can't talk about the cases necessarily. We can't. I can tell you that the Phoenix Canal murders was a Vidocq case. I didn't know that. And I ran into a Vidocq guy one day. I didn't really know he was a Vidocq guy until he said something. And he gave the opening talk to some conference I was at. And he goes, no, welcome, welcome, welcome. Phoenix Canal murders, welcome. And I went, what? What did he say? I mean, I was half asleep, right? But wait a minute. So I chased him down and I said, you haven't met me. I said, but I'm the lady that gave the name Miller. I'm the lady that solved it. And he goes, that was a Vidocq case. I don't think, he said, we told him that unless something came up, they'd never solve it. And the next thing I know, I get a call saying, turn on your TV. So that was one. The Boy in the Box was a Vidocq case. The woman in New Hampshire, her name was, I forget, Laura Kempton. That was a Vidocq case. And we're working on several others. Like we can't, if it's brought to Vidocq, I can't work on it unless I ask special permission. But if I bring a case to Vidocq, so I have brought a couple of cases to Vidocq that we're working on right now with them. So I may actually solve a couple more.
And they won't let you participate over Zoom?
No, I can participate. I can give, but I can't take it into my company and make an income off of it.
But you had said that you can't. You're in California. They meet monthly in Philadelphia to hear a presentation.
No, it's live. And now during the pandemic, we went around that, but no, it's live, and you have to be there. But you can be part of the post-presentation working group online, so I try and make those.
And they have in the group there are law enforcement people as well as
there's plenty. Yeah, plenty. And may I make a suggestion to your audience? I just watched Unsolved Mysteries the other day, and it had the case of John List, who in the 1970s
killed New Jersey, Westfield.
Yeah. That was what the people that solved that case were Frank Bender, who did the bust that looked just like him, and Richard Walter, who was a psychologist, putting input into that. So, and Bill Fleischer was the third one. Because of the John List case, that's why the Vidocq Society was formed.
Wow.
Those were the same.
I will say, if anybody doesn't know about that case, it's he's I don't know how to describe him. He killed his mother, his 3 kids, and his wife, and then he told the school system that they were on a vacation. They didn't find them for a while, and he had about 20 years before they finally caught up to him.
Yeah, and the reason they caught up was it was America's Most Wanted was a new show, and they needed something really kind of great, to show. And they hired Frank Bender to take his picture, John Lift's picture, and using the pictures of how his parents aged and how his children looked to form a model of what he might look like 20 years later, with the input from Richard Walter, who is a psychologist who would understand how his face changed because of the guilt, and because of what he ate and who he was and what kind of job he would have and whether he'd be married. And when they finished the bust, they were ready to do the show. And Frank Bender reached into a bowl of eyeglasses and he picked one and he popped it on the bust. And they showed that photo identical to what the guy looked like. And they had him within a few hours.
Incredible. Incredible. So here's a question. Recent trend to label DNA as junk science by lawyers like Josh Dubin that jurors don't understand, million times more likely. Any thoughts?
Defense attorneys will try anything. The end. Maybe there's a perpetual motion machine out there, or anti-gravity, they'll try anything.
Well, I think it's a little insulting to say that generally people can't understand a million times more likely and what that means. It seems to me that's pretty easy.
Yeah. In the Gilgo Beach trial, let me tell you, they had to do a Fry hearing on the genealogy part for many reasons. So of course I read the decision, whether to let the genealogy into the court and, because it had to do with, that's how they identified him initially. It was a very important decision. So I read it. It's like a 24-page decision. And the first half of it were the credentials of all the DNA lab people who developed the technology. And then the defense presented their expert, which was one paragraph for each one. He had two experts. And the second one was a student of the first one. The second one took 10 years to get a college degree. And then he started his master's and he quit because he didn't think he was good enough. And that was so defense will try anything. You have the real people out there with pages and pages of resumes. Defense, will try one paragraph to throw something in.
Yeah.
Go ahead.
We're talking to a former prosecutor, so.
Okay, there you go.
Yeah. So what is your prediction, if any, as to where DNA advances are going to take us in the next 10 or 20 years? Do you have any feel for what might be the next horizon?
Yeah, more and more with less and less. We'll be getting DNA from places that, of course, the problem is when you get really low-level DNA, it might be contamination, right? Because I could brush up against you and say, "Hi, Joe, how you been?" and tap you on the shoulder. Your touch DNA is there, right? Mm-hmm. So more and more with less and less. It's going to spread internationally. There's going to be, a lot of laws, a lot of policy, a lot of procedures, developed that are consistent with each country's legal system. There's going to be more people trained, more people very good at it. It will, like, it's work its way into law enforcement. They are places that have units now. There's going to be ways to handle mixtures. There's going to be ways. Some of our very old remains are contaminated with bacteria. So we have to remove the bacteria using, certain process. That's going to get more efficient. So you're going to get that little tiny piece of DNA in the middle of all you're going to get the needle in the haystack. And it's going to be so much easier. You're going to have bigger databases. You're going to have people kind of more okay, and understanding that if your third cousin is a violent offender, it has nothing to do with you, I think people will calm down on that point. And I see a lot of that happening right now anyway.
Must be very exciting and rewarding to know that you were in at the very beginning of this really new phenomenon that's gone so far, so fast. Pioneer, in advancing it.
I got to keep my voice active or I'll get swamped out with all these other so-called pioneer experts, and I'll say, wait, step aside.
I don't think you have anything to
it's
worry about. Well, thank you so much. This was so interesting. I don't know if there's a question or two left. Maybe we can take those, but I really don't want to.
Well, Joe, if they have questions, you can just send them over to me if we miss any,
that would be terrific.
And I'll be glad to, type out an answer too.
I hope everybody that very, very much, because we will have people who will not have seen this live who will watch it.
Okay.
And that's very gracious of you. So thank you so much.
Okay. Yeah. And, keep in touch. Yeah. Thank you for having me on the show. I really enjoyed it. I hope people understood what I said. I try to explain
on your test, because science and I don't have much in common. We have a passing acquaintance. So if I can follow it, I think you can guarantee that everybody else followed it also. Okay. You were very clear. Very clear.
Do you know how to spell DNA? Is that right, Joe?
What?
You know how to spell DNA.
I do.
Okay.
A&D.
Step one. I heard this comedian, and she's interviewing somebody, and she says, "Professor, yeah." He says, are there people with both D and A, or do you have D and then you have A? You have D and A. And he's like, doesn't know what to say.
Well, I don't know. Well, we really appreciate it. I know you're very, very busy. And so to be able to give us this much time is just terrific.
Oh, don't worry. I do this. I enjoy it. And you have to have some fun, You can't, I say, people say, how you doing? I said, well, murders, homicides, rapes, kidnappings, burglaries, day in, day out. You got to have some fun.
Well, I will say the work you do and the work that other experts in, the GPS systems and everything, it's not simply finding the criminals after they've committed the crimes. I think you make it much harder for people to even consider doing a crime, because it is so much easier for law enforcement to catch you these days. Well, and that's a wonderful accomplishment.
Yeah. Well, keep in mind too, a lot of crime is on the moment. A lot of murders are on the moment. And so you don't think, oh my God, I'm gonna be caught. You're really mad at somebody, or you're chasing them down, going to shoot them or something. So,
and they're also not very good at predicting consequences. I mean, I know the cases that I was teaching, you say, something like, for example, you go in to burglarize the house next door because you think the resident has money. And it's only after you're in the house without a mask that it occurs to you for the first time that your neighbor will be able to recognize you. And then you commit a murder. I mean, this inability to project what's going to happen at stage 2 if you act in stage 1. It's a signature characteristic of a whole class of.
So I think that it will help prevent some crime, but it won't be hermetically sealing us in a nice environment where there's no crime. A lot of it is passion crimes and on the moment. So. And that.
Or you think you're smarter than law enforcement, and you're smarter than the science, and you can outfox everybody, and it's not true.
Yeah, well my comment on that is nah.
Yes, right. That's true. Well, thank you so much. And we're just delighted that you're able to give us the time.
Okay, well, it's been fun. So, send me any questions that you snag on the chat or otherwise, and I'll be glad to try and I'll be back sometime. Invite me back sometime.
Well, I'd love to have you
take
back.
a breather and you kind of
absolutely fascinating.
Okay. Well, look, we'll say bye, and you have a happy holiday.
You too. You too.
Whatever holiday you celebrate, have a good one.
Well, you can tell behind me, I'm celebrating Christmas. Thank you. All right, so long. That was just, I hope you all enjoyed it as much as I did. I thought that was just incredible. And I did learn some things about how DNA operates. And you can see proffers, those of you who are members, we're going to do a sneak peek of a cross-examination of Wendy Adelson by Catherine Magbanoa's lawyer. And so that will be coming up in a little while. And we're also going to do, for members, I've had some requests for to tell people about my background, and I just can't imagine that anybody would be interested, but I had enough requests that we'll probably do that as a members only also. And we'll be doing something Friday night. I'm not so sure. Oh, it's out now. Okay, so that members only extra credit on the cross-examination of Wendy, and you can catch right now. And I will be doing something Friday night. I'm not quite sure what I want to do on Friday night. If you all have a particular request, and let me know, I might be able to manage a request. And otherwise, I guess between now and then, those of you who celebrate Christmas will have celebrated Christmas. So ciao, proffers, ciao a tutti, and arrivederci, which means see you again, sort of.